All right, welcome back and thanks for tuning in again. So this is going to be a bit of a filler video. It has to do with the Briggs and Stratton Model A kind of rebuild and load testing. I didn't get to reassembling that little engine yet. Had a really busy week at work, and what I'm about to show you I actually intended to do off camera, but since I didn't get the progress done that I wanted to get done, I figured we'll make a video about this. So we got two things to do. We've got to make the brake drum, so to speak, for the Prony brake. That's on the lathe here, slab of steel right here. And then I've got to make a Venturi for the carburetor because I managed to break that when I was cleaning the carb. So let's take a look at the two jobs today and get started. So here's the first job for the day. Got this slab of steel of some type that I got from the steel yard this past week. I have no idea what alloy it is, but it's roughly 2 3/4 inches long by about 5.5 inches in diameter, and this is going to be the brake drum that will be attached to the crankshaft of the little Briggs engine that the lever arm of the Prony brake will grip onto. So we've got to, what I want to do is clean it up, face everything off, get it to a pretty fair dimension, and cut almost like a seat or a surface in the face here that it's going to be a piece of wood that the wooden brake shoe will drag on to actually grip and apply a load to the engine. So that's job number one. Job number two is over here on the bench. This is the carburetor for that little engine, and I definitely had to take it apart. It's got a lot of that white rust in there. Yeah, it's just pot metal, some kind of zinc alloy here. But what I managed to break is the Venturi for the carburetor, which sits in this little hole right here. I really did need to take it out because of this little air bleed port here to be able to clean that. So the Venturi, well, parts of the Venturi are right here. So here's the actual die-cast Venturi. You can see the little, I guess the minor diameter right there. And it's very, very thin wall. Sits right in this hole like that. And there's a little flange. Here are the pieces of the flange. And one of them has the hole right there. So I'm going to try to duplicate this part on the lathe in aluminum. So I wish I had a smaller lathe at this point, would be nice. But the part itself won't be hard to make. The hard part is going to be making these tapers. The gradual taper on this side and the sharp taper right here. So we'll see how that goes. But let me fire the generator up and we'll get started on the pulley. Or not the pulley, the brake drum. Alright, well, making the first cuts on it, just facing this end off. You might see that the stock is wobbling quite a bit. I mean, the ends looks like bandsaw cut. So, I really didn't even use the indicator on it. I just, looking at the end that's gripping the jaws, I tried to get that to where it was running concentric. But I guess, like I said, because the end wasn't cut perpendicular, that's causing me to have some wobble out on the front. So after I get this face cleaned up and I take some off the OD, I'll flip it around, get it set nicely in the jaws, and then I'll do the same thing. Indicate on the nice face, and then face the other end off. And then we'll be ready to actually do some work. I'm not going to film this whole thing. It seems to be machining quite nicely. It's not very tough steel. Again, still not sure what alloy, but look like it's not going to be too difficult to machine. .32. Let's take it down to 5.4. So I'll just take another 15 thousandths off of it, and I think that'll be good. We'll take it nice and slow so we can get a good surface finish. 15. Wow, not breaking the chips very well at all, huh? Where did I set my caliper down at? Oh, there it is. Look at that, 54. 5.4, I should say. The old South Bend's right on the money. Well, I figured that before I spin the piece around in the chuck, I should go ahead and cut the groove to make the one end of the recess where the brake is going to ride. So I got the old dreaded cutoff tool in here. Let's see. Touch it off to the face there. You zero this indicator out, and I want the lip to be a 1/4 inch. So, and the cutoff is 1/8 inch wide. So I got to go 375 thousandths in. There's 1, 2, 375. Right about there. That should leave me about a 1/4 inch. Where's my little scale at? Man, I don't know where it's at. Okay. Just use the caliper. Yep. Okay. Got the lathe in back gear. I'm going to go a 1/4 inch deep as well. Okay, just touching there. Let me zero this dial on the cross slide here. I'm just manually feeding this. It seems a lot happier if I really keep a good amount of tension on it. If I just lightly let the tool touch, it really chatters a lot. There's 90 thousandths, 100 thousandths. There we go. That wasn't so bad. Well, so now that I have that groove cut to 250 thousandths, I'm just going to use a turning tool and turn in this direction and work up to that groove. Just kind of relieve as much material as I can here before I flip the part. And then I can, well, like I've been saying, I can face the other side, turn the OD that's in the chuck right now, and then do the same thing, you know, cut the groove and then finish out the turning, and then just bore the hole through it. Okay, well, I lost the audio in the next couple clips, but I got the workpiece flipped around and in the jaws, got some copper there to prevent marring the surface. We got the dial indicator set up, so go ahead and spin her up and see what it looks like. Looks like about 1/2 thousandth worth of run out. So I'm going to call that acceptable for this job, and we're going to move on to some more machining. Alright, so we're cutting the groove on the other side now. Seems to be going just fine, just like the first. I think that the trick here is just to keep that cutoff tool, you know, really dug into the work. That way it doesn't chatter. So once we get this done, we can machine out that leftover section there. I already got this end faced off, and then we got to drill the hole. Alright, well, all the turning is done. So just drilling out the hole now. That's a 3/8 drill there. The Briggs crankshaft is 3/4 inch, so that's what we're going to end up with. I'm just going to drill it with a 3/4 inch drill. I'm not going to bother reaming it. Really wouldn't do much good anyway because of how pitted the crankshaft is on that engine. So, not going to worry about it. Alright, well, I just started drilling the 3/4 inch hole, the lathes in back gear. Just plowing through it. That's a nice sharp drill. Man, I think my generator's running out of fuel. Every once in a while I hear it, I hear the RPM flutter a little bit. I haven't checked the fuel in a while. It was only a little above a 1/4 tank when we started this job. So, I'm not sure how much is left in it. It's been going for about 3 hours now. Do you hear it? This isn't really much load for the generator, unfortunately. So, if I use the lathe a lot, I really need to load bank the generator afterward to clear the cylinders and try to get some of the built-up carbon off the injector tips. It's an air-cooled Deutz. Well, technically, I guess you call it oil-cooled. Oil and air. So, really not too much of a problem with that, with wet stacking, because the cylinder temps are always a little high. I recently put one of those silicone oil pan heaters on it, and it makes a world of difference starting it up. Like tonight it's going to be, I think, 21 degrees out. So tomorrow when I wake up, I'll come out, plug it in, let it warm the pan, warm the oil for a couple hours, and it'll start right up. It doesn't have glow plugs. It has an intake heater, which is not connected. I'm not sure if it's any good. One of these days I should look into that. Well, I guess one of these days I should get myself set up with a variable frequency drive. I want to keep all the machines three-phase. I mean, between the lathe, the milling machine, and the disc sander, and the shaper now, that's all three-phase. Those are all three-phase motors. I'd hate to have to scrounge up a bunch of single-phase motors. I'd much rather use a variable frequency drive that can take 240 single-phase and make 240 three-phase. I also have to completely redo the electrical distribution in this shop, so once I get that done, we'll worry about VFD. For now, fuel oil is cheap enough that I can keep running the generator. Well, there you go, hot off the lathe. One Prony brake drum. Got a lot of weight to it. I think it weighed 18 pounds. You buy it by the pound at the steel yard. Before we did this, and probably doesn't weigh too much less now. Didn't really do a lot of material removal, but it took long enough. So let's make this little Venturi here. Well, I added 5 gallons of fuel to the tank of the generator, so that should get us through this job. So here's a cross section of the Venturi that we got to make. Got a lot of material to remove, but this is the smallest slab of aluminum round that I could find, just laying around. So yeah, there's our dimensions. There's the minor diameter is 1/2 inch. We got 1/8 of an inch here for the inlet coming from the air filter. This angle here is about 44.5 degrees. Yeah, 44.5, 45 degrees. This angle right here on the outgoing is 14 degrees. So those are going to be the two little difficult parts of this project. The rest of it, it's pretty much just a bushing with a flange on it. So that's easy enough to make. So yeah, let me get started here. Or continue, I should say. I'm already started. Okay, so the major outer diameter is turned down, that's 7/8, and now I got a 1/2 inch ream here. We're just gonna ream the ID, since the minor ID is 1/2 inch. We'll just go ahead and do that. I'm just jumping around here. I don't want anybody thinking I went and increased the diameter of the Venturi to try to get more horsepower out of this thing, or anything such like that. We're just duplicating the original part. And we're just about through. Yeah, we're through. Alright, so here's my setup for boring the taper on the inlet of the Venturi here. So I just have this little boring bar in the tool post here. The compound is set to 44.5. So, and I've got a little line scribed in on the bluing there. Too fast, zoomed in too fast. Can you zoom in on that? Focus, please. Right there. That little line you can see right in the ID. That is 1/8 of an inch in from the outside of the flange here. So pretty much what I'm going to do is I'm going to cut as I draw the bar out, more or less. So I'll feed it in, back out the cross slide, and pull the tool out with the compound. And when I get to that line, that should be correct. All right. Start it up. You know what? You guys are going to be in my way. Alright, well, sorry for the poor angle, but this is the best way to keep you guys out of my field of view here so I can see what I'm doing. So I'm about to do the taper on the inlet to the Venturi here. I got the compound set to 44.5 degrees, and I'm working up to a line that I have scribed in the bluing there. Almost there, maybe another 2 passes. That should be it right there. Maybe not quite. Now, I still see a bit of the line. Let me stop it and clear that hole out. Almost there, not quite though. We got a little burr forming here. Take that off real quick. Should be it. I got the first tapered inlet for the Venturi done. Here's the original. I'm talking about, where is it? That taper right there. It's a pretty good approximation, I think. So, alright, well, now I'm going to go ahead and cut it off and then flip it around, and we'll grip this on in the chuck, and we'll do the other taper, and we'll be done. Well, I think I just goofed up, and I missed the best shot, which was where the two tapers meet. You can't barely see down in there, but we got the 14-degree taper here. The surface finish isn't the greatest, but a little Scotch-Brite will take care of that. Oh, watch out. And can you see that sharp edge back there, right at the tip of my fingernail? That is the minor diameter of the Venturi, or at least it should be. That's where the 44.5 and the 14-degree taper meet, and there you go. That's about it. I think this thickness here of the lip, I left that a little large when I cut it off. That's supposed to be 70 thou. Where's my caliper at? Let's take a measurement of that minor diameter there. It should be 500 thousandths. .498. Am I right in the center? Might be a burr or a chip in there. Oh, 501. I'd say that's pretty good. There you go. One Briggs and Stratton Model A Venturi. Still have to do a couple things to it because, ooh, don't lose it. It's not going to fit in here right now because there's a little bump where that hole is. See that? I got to do that with a hand file on here. Just kind of dress it up so that it can slip right down in there. You know what? Let's check that width too. Like I said, 70 thousandths. Let's see where it comes in at. Oh yeah, I got about 30 thousandths to take off of that. No problem. I'll do that with a file. Okay, well, let me get that done. All in all, I think it was a productive day. So there's the new Venturi. You see that groove I had to cut in there. Still have to drill the little hole for the air bleed, but fits right in the carb like this. Nice and snug. And the little main jet tube comes out through there. Still take a little bit off of the top here, but it's a nice snug fit. So that's good. And then of course got the drum done. So yeah, productive day. So hopefully next week we can get the engine put back together and run it. So appreciate you watching.